From IMTS 2014. This is TechnorazziLIVE. I'm Dirk Ducharme, Editor-in-Chief of Quality Digest, and we're coming to you from the ZEISS Industrial Metrology booth here at IMTS 2014 in Chicago. And we're going to be talking today about some new technologies from ZEISS Industrial Metrology, as well as some more technology and software and tools that will help you be more productive and your measurements be more accurate. And to start us off, we have David Wick. He is the leader of product management for ZEISS Industrial Metrology. David, welcome to our roundtable this morning.
Great to be here, thank you.
And we're going to be talking about new technologies, right?
Absolutely. We're going to start with just a bit of background. As you might know, ZEISS has been in the industrial metrology business for 40 plus years and has a reputation for bringing innovative new solutions to the industrial metrology market. On display here at IMTS are products that embed those technologies, which range from very simple styli like I hold in my hand to very, very sophisticated X-ray technology in the X-ray machine behind me. So we're one of the few companies in the world that can span that range of technologies focused on industrial metrology.
Okay, and I think we're going to be talking about individual pieces of equipment, right?
Absolutely.
Right? Okay.
We certainly are. And those technologies are embedded in all the pieces of equipment around the display here, ranging from our shop floor Duramax product to our most sophisticated Accura CMM. And they include multi-sensor systems like our O-Inspect machines and our newest CONTURA CMM that's on display.
Okay, and tell us a little bit about the CONTURA.
The CONTURA is completely revamped. It's got 23 new models. Its basic theme is that it's incorporated technologies that were previously only available in the most high-end, precise CMMs and brought them down to the value-conscious CONTURA product. That includes a line scan capability for doing reverse engineering. It includes navigator capability for precision, from being more productive in actually doing measurements. And it includes an energy-efficient air saver capability that actually shuts the compressed air to the machine off when the machine's not being used and can wind up saving the customers all kinds of money.
It's interesting you mentioned that. I mean, that's something a lot of people don't think about, is you have a lot of CMMs, or a lot of shop floor equipment in general, constantly has air pressure going to it. The compressor's running. These are huge compressors very often, eating up a lot of energy, and a lot of times when you don't need the air running, right?
Exactly. And many of our customers use the machines one shift a day, 5 days a week, and by turning it off on the off hours, you actually pay for the option in less than a year.
Wow, that's interesting. Okay, so energy savings. You mentioned Navigator. What is that?
Navigator is a piece of expert software that analyzes where the CMM sensor has to move from the left, right, top, bottom to most efficiently measure what needs to be measured. By most efficiently moving around the space, it shortens the measurement time. And what that does for the customer is let them measure more things per day, per week, per month, and use the machine more productively.
So these are, so a lot of, I think what you're going to be talking about today with the other equipment you're going to be speaking about is some of this is accuracy oriented, some of this is productivity oriented, right?
Exactly right, exactly right. Navigator's a productivity enhancement. We've done some other things in our machines to make the accuracy better as well.
Now I think you had told me earlier that, was it the CONTURA that is really kind of taking a lot of the technology from some of the legacy machines and putting it in a package that's what, a little less expensive, but yet with all the same accuracy and so forth? Was that the CONTURA we were talking about?
That's exactly right. That's the CONTURA. We brought the the Navigator. We brought some other innovations down from our higher end Acuras and Prismo machines and brought it down into the CONTURA. So it gives us a really solid platform for those value conscious customers that are in medical, aerospace, or industrial machining applications.
So just to clarify, so even though they may be getting, as you say, more value conscious customers, which we would call customers who have less money to spend,
yes,
they're not sacrificing quality or accuracy or anything like that. Right?
Absolutely not. The machine still says ZEISS on the label, and we've actually packed more features into the similar price point.
Okay. Anything more you want to tell us about the CONTURA before we move on to some of the other products?
The other thing I'd say about it that's new is that we've expanded the size. We've made and are offering sizes that can inspect larger objects, and that's been something that customers have asked for, and now we've done it.
So I'm assuming there's several versions of the CONTURA, different volumes. Is that correct?
There's about 9 different versions and about 23 different configurations.
So what would be, just an example of just roughly the smallest volume and the largest volume?
The smallest volume would be 700 millimeters by 700 millimeters by 600 millimeters. Okay. And the largest would be 1.2 meters by 1.2 by 1.8 by 1 meter.
Okay, so application for this mostly what, aerospace and automotive typically, or?
A lot of automotive customers, a lot of aerospace customers, a lot of contract machining companies, some medical companies I know of that have to inspect larger assemblies. So yes, it's all over the map.
Okay. So that was the CONTURA. I think there's some other equipment on display here as well, right?
There's a lot of new equipment on display here. Right behind me are 2 new standalone measuring instruments. One is called a SurfCom, and that's a surface finish measuring instrument. The other one is called a RondCom. It's a roundness measuring instrument. It measures how round a spindle is and how flat it is. I think one of the most exciting new innovations that is on display here is something we call our ROTOS, or R-O-T-O-S. It's a surface finish sensor, and it is a sensor that mates with our Acura CMM so that customers can now measure form, shape, and surface finish on a production level CMM, saving them a lot of time. They don't have to take the piece off, move it over here, measure it, bring it back, and getting all of that inspection data in one consolidated report. And our customers tell us that those 2 benefits, saving time and common reporting, are huge for them.
So you're saying that you've essentially married a surface roughness and a form measurement into one machine?
That's right.
Do I have that right?
That's exactly right.
Now, are they sacrificing anything by combining these two, kind of sub-optimizing one over the other?
You're not sacrificing anything in terms of reporting, because it all comes out the same. The ROTOS sensor is a slightly less robust or accurate surface measurement than a standalone machine, but our information and our intelligence says it's still plenty good for the customers that want it.
So let's talk about that a little bit. So some of the innovations that we're seeing here at ZEISS Industrial Metrology obviously are being driven by customer requests, right?
Yes.
So how does ZEISS gather that information? How do you know, for instance, that somebody needed a form measurement and surface roughness combined into one machine? I'm assuming that wasn't just, oh, hey, that's a great idea, let's do it. That was some sort of feedback, right?
Well, there's a lot of ways we do that. We have a customer base of several thousand customers in North America alone, and we're constantly in contact with them through our applications engineering force, through our sales force, and so we're always getting feedback on how are our current products performing. And we always ask, what needs do you have we're not fulfilling? So by asking those questions, we can constantly get information back and gather it up and say, there's a trend. Customers in this application are all saying they'd like something like this, and then we're on to something. So it's a constant feedback, constant mechanism of asking, listening, and then consolidating what they want into a plan to make a product.
And I know you don't want to give away any secrets, but kind of what's your rough turnaround time when you, for instance, you get a great idea. You say, you know, we really need an instrument that combines surface roughness and form measurement. What's your kind of your innovation idea to production timeline? Are we talking a year or 2 years or 6 months? Or?
It depends. The easy answer for me would be it depends, but it really does. It depends on how complicated the innovation is. If we have to put one thing together, make a simple iteration, put 7 new technologies together into one machine, and it takes longer. We have a new machine called XENOS, X-E-N-O-S, which is the most precise and accurate machine of its kind on the market, most precise CMM on the market.
CMM? Okay.
CMM, and that took us several years to combine all the innovations in materials, in software, in sensors together to achieve what we wanted to achieve. So simple things happen very quickly. Really going outside the box and stretching takes a little longer.
Now, you know, I see a couple other products here that I'm not sure we've touched on in a lot of depth. I think something you call the Tempar, right?
Yes.
What is that?
The Tempar is a standalone computer system that we put inside of the measurement room where our customers put their CMMs. CMMs often have to operate in a temperature-controlled environment, limited temperature range, controlled humidity. And what Tempar does is it charts all that. It has sensors in the room that measure air pressure, humidity, and temperature, charts all that over time, so it lets us know that the room is indeed in the specification range we need it to be.
Now, does this feed back directly to the instrument, or is this strictly for monitoring, so the calibration lab or the guy who runs that lab knows what's going on?
It's strictly for monitoring, but the interesting thing about our system is you can check it from anywhere. This is just like checking your home burglar alarm system when you're eating out at a restaurant. You can go on your smartphone and access an address on the web, and you can see all the readings from your measurement room from wherever you are.
Can you set alarms?
Believe so.
Okay.
Believe so.
Oh, that's interesting. So, so the whole idea there is just that in one piece of equipment, you have the ability to let the lab manager, whoever, know that you're staying within spec, and there's no surprises when they come in and find out their lab's at 80 degrees, right?
Right.
Yeah.
Exactly right.
PI Web, what is that? I saw a sign out there for something called PI Web. Or PI Web or Pi Web? What do you call it? Pi Web. Okay.
Pi Web. Pi Web is a piece of software that we're introducing here at IMTS, and what it's aimed at small and medium-sized businesses that have one or more of our systems, our CMM systems, and want to consolidate the data together. Let's say, for example, you're a medical company and you have 5 of our machines, and they're all inspecting the same product the same time. What you want to do is you want to be able to plot the aggregate of your inspections, and or say, gee, results from machine number 4 don't match the other ones. I think we ought to check that guy. So it automatically consolidates the quality data from all the machines together into reports that everybody can see.
Okay. Let me ask you a question. One thing that obviously as an industry reporter, one thing we always want to know is what seems to be the type of technologies that you see customers really desiring. And is it more, are you seeing a growth in, let's say, CT, computer tomography, or is there still, everybody wants a CMM, or, the combined machinery? What are you seeing as growth?
I think that's a question that Kevin might be able to answer better based on his experience.
Okay, well, actually, go ahead. You're going to be talking about something very specific later, but go ahead and address that question if you don't mind.
Well, clearly.
And by the way, this is Kevin Legacy, and you are inspection and
responsible for inspection services and programming services at ZEISS.
There we go. Okay.
Yeah. So we've seen a tremendous growth with typical conventional CMM technologies, both with scanning probes and non-scanning probes. Many of the systems are on display here at the show, but one of the very innovative technologies that's really starting to get an uptick in the level of questioning from our customers is our Metrotome, which is it's a coordinate measuring machine that uses an X-ray sensor. Nothing more, nothing less, but it allows us to use X-rays like you have in the hospital to inspect parts. Doesn't do everything, but what it does do, it does very, very well.
So CT, I'm assuming that there's kind of this growth in CT because more and more parts just can't be inspected in traditional touch probe or laser scanning or whatever type methods, right?
Yeah. Well, in the case of let's say clear plastics, a difficult challenge because even with non-contact, light has a problem when you have clear plastics, the tube reflections, or if you have translucent materials, or they're different colors of material can be a real problem, but with X-rays, not an issue at all. And similarly, if you have parts which are very flexible, like is the case with plastics in many times. So X-rays again are the perfect technology for inspection in those kinds of parts, and clearly to be able to see inside a part, which you can't do with any other technology non-destructively.
Okay, all right, thanks. So back to you, David. So we touched on kind of the key technologies that are introduced here at IMTS. We talked about the CONTURA, your new bridge type CMM, the ROTOS, that's ROTOS, right?
That's right.
Which was your surface measurement on a CMM. We hit all the high points on those?
We've hit on all the big ones. Some of the other machines that we're not showing here have some of our more advanced technology in them. For example, our Xeno CMM relies heavily on the use of silicon carbide material to make its moving parts lighter and stiffer. It's the first time we've done that at ZEISS, and we're way ahead of the market in terms of deploying that material technology in our products.
Okay, so let's leave hardware here for a little bit, and we may come back to some more of this later on. I want to get over here to Alicia Anderson. Alicia, you're the Customer Education Manager, is that right?
I am, yes.
And is there a lot going on with customer education?
Of course. So I want to talk a little bit about our software as well as our training programs. So with CALYPSO 2014, we've had a lot of new enhancements that come out. One of the big ones is we've enhanced our touch capabilities. So we have a lot of different options with some swipe options with touch, and we can dock our protocol and have very interactive responses within the software on touch. We also have redesigned how you can provide the layout in CALYPSO, so you can fully customize the overall menus that you see, what's available, everything on there is easily accessible. So.
And this is in CALYPSO, is that what you're saying?
That's correct, yes.
And were you going to show us a little bit about I think you had a little demo you were going to do for us? Well, tell us a little bit about what's going on with kind of your module-specific courses and kind of going in depth on what people can expect from education from ZEISS.
Yeah, so in training we have a lot of different options. So we have our standard courses that we offer. It's our basic and advanced courses. And that really gets into the fundamental programming of CALYPSO. Everything from how to use the CMM, some basics on qualification, all the way up to some in-depth optimization and efficiency tools for programming in CALYPSO. So we really try and marry that together so that we can really provide a solid knowledge foundation for customers to use it in their applications. So we also offer some module-specific courses, as you mentioned. We have a course for our Curve software. So it's a 3-day course that really focuses in on how to use Curve in different applications and some of the different options with that. We have a 3-day course for PCM, which is our parameter coded measurement. That one you can go in and you can really get a good foundation to how to program, right? And some of the flexibility that we offer in CALYPSO with that module. It's usually used in things like part families. So I have a series of parts. I don't want to write 10 different programs. They're essentially the same. They're just different sizes. And so I can use PCM and really integrate that, have operators scan in for the parts. We can use barcodes and integrate that with PCM. So, I mean, there's a lot of functionality that comes with that module. And then we also have one called Freeform, and that's a 2-day course to really integrate surface measurement, really looking at profile for non-standard geometries.
Okay, and are these courses, are they typically something that's offered when somebody buys a brand new piece of equipment from ZEISS, or could they come to you at some later time and sign up for courses or ask for courses?
We do both. So anytime a system is sold, we always incorporate BASIC with it because we want to make sure that customers are able to fully utilize their system. But anytime you can come to us, we have all of these different options available. So we provide both in-house training at our facilities in Maple Grove, Minnesota, Brighton, Michigan, and also Irvine, California as our ZEISS facilities. We also go on site to customers as well so that we can provide them with training in their facilities to really utilize their parts, their equipment, to best address their needs as well.
So you can bring them up to speed on how to use their equipment right on site.
Exactly.
With their own equipment and not using somebody else's, or using equipment that maybe you have in your lab and they're actually with their own equipment, right?
Exactly, yeah. So we try to offer a lot of different options at our training facilities so that we have the ability for them to use the different sensors and bridge type systems that they would have. But sometimes the need is really to go on site and to best address that. So
now, I know a question that probably comes up a lot, and I'll throw it at you, is does this training, would it apply to older, legacy ZEISS? I mean, CMMs last forever, so somebody's got a 30-year-old ZEISS CMM. Does this training apply to them as well?
So most of our training, we try and keep current just like with the software. So we move forward and incorporate the new functions in the software in our training programs as well. But some of the fundamental theory on how to program in Calypso, that carries throughout. It's always been a visual-based program as far as how to program in Calypso. As far as how you qualify probes, and some of those fundamental knowledge concepts are carried throughout from Calypso 1.0 on through. So we can address some of those needs, but there are a lot of enhancements that have come down the line that we really, include in our training programs now that were not necessarily a part of older versions.
You were mentioning to me earlier that ZEISS Industrial Metrology goes beyond simply training on your own equipment. You have kind of a university kind of a general measurement or metrology training, is that right?
We do. We have a certified training course that's called AUKOM, and it's built.
How do you spell that?
AUKOM.
AUKOM. Okay.
Yeah, and it's built to be it's not a machine-specific course by any means. It's built to really provide a foundation in metrology. So everything from understanding units and conversion concepts to hand tools, all the way up to how to integrate a CMM into your quality system, talking about environmental conditions and concerns, talking about how the software is really fundamentally working with the CMM to help with those measurements, and talk about what do those measurements mean. So it really provides a good foundation across the board in metrology.
Okay,
So.
and before I want to touch bases on that, but just one second. If you have any questions about anything that we're talking about here on the show, you can send your questions to techno-live@qualitydigest.com. I think there might even be a address there on your player page. Send them to techno-live@qualitydigest.com. It can be related to anything that we're talking about right now, or anything related to ZEISS equipment, and we will try to get your questions on the show. So let's talk about this whole issue of just general purpose metrology training. I mean, one thing that we run across as a media company is really a lot of customers really are starting to, I guess, complain, for lack of a better word, of the lack of skilled metrologists, people who really understand how to take measurements. They're coming in, and sometimes there's this impression that I've just bought a brand new piece of ZEISS Industrial Metrology equipment. I should be able just to throw something down there on the CMM, punch a button, and it's going to measure for me, and it's going to be perfect. But that's really not the case. There's a lot that goes on behind taking proper measurements. And so my question is this drive for having a university, is that driven by just requests from your own customers saying, boy, we need to train people up because they're coming in and they don't know what they're doing?
Yeah, it's to bridge this gap between being able to use the system and understanding what those numbers mean, right? We're building up that foundational knowledge, that theory that goes into metrology, right? Because it is easy to use the equipment, and to program it. It is very easy to use, but to really understand what you're doing and what those settings mean and things like that, we do have to take it to a deeper level, and that's why we brought AUKOM over. It was established in Germany about 10 years ago, working with a German university and a number of metrology manufacturers, and the idea was to bridge that gap ultimately.
So that's interesting. So you said something I didn't realize. So the curricula is actually came from different different metrology manufacturers.
It did, yeah.
So like even like basically, I guess we can put it this way, is competitors coming together saying, look, this is the knowledge that people need to use, need to have to run any kind of equipment, ours or anybody's. You need to know these, metrology basics, kind of the principles of measurement, I guess you would call it, right?
Exactly. It was a gap that was seen all the way around, and so the idea is to bridge that and to offer a training course that will help get them from theory to use and understanding.
And how is this training provided? Is it video? Is it on-site? Is it in person?
It's in person at our facilities, so we're offering it in Minnesota and Michigan at the moment at our facilities. We also do offer on-site as needed for larger groups as well. And it's primarily lecture-based, discussion-based, and there is some interaction as far as showing on some of the systems how sensors work, you know, just giving some examples in that regard as well.
And David and Kevin, I mean, when you're working with your own respective customers, either on new equipment or inspection and programming, is that some feedback that you're getting also that, hey, how do I get people trained up on using equipment or just metrology measurement basics? I mean, do you get that from your own customer base?
For sure, they're always looking to get better, and oftentimes they're looking to improve their own processes internally. How can we do a better job in our lab so that we can deliver parts better to our customers? And you know, we would like them to ask more questions regarding training and education, and to come to more classes. But no, it's a constant loop. They're always asking.
And I would assume, and maybe this is more for you, I would assume that it wouldn't be unusual for people to come to ZEISS and say, hey, look, I have this piece of equipment, I spent this much money on it, I'm taking measurements and my measurements are all over the place. And you have to maybe educate them as like, well, maybe your measurements are all over the place because you're not measuring properly? I mean,
it's very possible. Like many other pieces of equipment, the equipment is only as good as the person who is running the equipment. And we can take the best piece of equipment that we make, and in the hands of an unskilled or untrained person, it's not going to do them much good.
Is there a lot of interest in the Occam University?
We're seeing a lot more interest now. Now that it's become more known that we provide this type of training, there is quite a bit of interest, especially with some of our larger customers. And you know, it's starting to kind of trickle out throughout the community now that it's a course that's available. But in the time that I've been at ZEISS, I've had a number of people ask for something similar. You know, how do we bridge this gap with really understanding metrology? Not just how to measure, not how to use the software, but how to understand what I'm doing and why I'm doing it.
So let's move on from software for a little bit here. Sure. And we're going to, Kevin, we've already touched bases with you a little bit. This is Kevin Legacy again, Manager of Inspection Services and Programming for ZEISS Industrial Metrology. And your responsibility is, well, I guess, inspection and programming.
It is.
That would make sense.
It is.
Tell us about that.
So what we're doing now is we're complementing. We're complementing our products, we're complementing our education center, and we're closing the loop with our customers. We're providing something that our customers they've asked us for a long time, which is, you know, we've got people going on vacation, or we have overflow. Can you help us to check our parts, or can you help us to write programs for our parts? And so we now at ZEISS are offering a series of centers across the country, both in Brighton, Michigan, Minneapolis, Minnesota, Irvine, California, and from each of our ZEISS Tech centers, we're offering programming and inspection services using all of the pieces of equipment that we provide here at ZEISS. We are, I guess it's important to note that while we can do just about any kind of inspection, what we're really focusing on is providing services and technical know-how with typically difficult inspection tasks. Let's say gears or blades or rotors, things that, yes, anybody can check, but there are some tricks to the trade, and we're here to help if people need help with those kinds of things.
So you're saying very often people might have the equipment that would allow them to measure gears or turbine blades, but it's kind of a specialty measurement job, and they just feel more comfortable sending it out to somebody like yourself to do the inspection for them.
Sure, and it can be a combination of us writing a program for them or doing the inspection, but working with that particular company's inspectors so that the next time around they can do it themselves.
Okay. Let's talk a little bit about some equipment that you're doing programming and inspection equipment for. I understand you touched on the Metrotome not too long ago. Why don't you just kind of recap that a little bit.
So Metrotome is definitely a leading edge technology for us, and it allows us to check. It is, as I said earlier, it's a CMM that uses X-rays, but it allows us to check components, typically plastic components, low density things, with the precision of a CMM. So we are offering services on a full-time basis in our labs, both in Michigan and in Minneapolis, coming soon, next month. And so basically our turnaround is 48 hours. Give us the parts and you'll have your results in 48 hours.
Okay.
Yeah. Other machines though, not limiting what we do to just our Metrotome, but on the very high end, our MyCura measuring machine,
which is a CMM?
It is a CMM. It's a sub-micron measuring machine from ZEISS. We use that equipment in all three of our labs, as well as our F25, no longer a product that can be purchased, but by far the most accurate measuring machine ever produced by ZEISS.
So when we say, I'm always interested in accuracy stuff because sometimes it just amazes me. So when you talk about sub-micron accuracy on the MyCura and on the F25, what are we actually talking about?
So on the MyCura, it's a 0.8 micron machine. Yes.
Accuracy. Wow. That's. And are these small volume machines or larger volume?
The F25 is a 4-inch measuring volume, so very small, and it was purposely designed for doing micro-machined components.
Okay.
So think watch components, things of that size or smaller. The MyCura is a much larger machine, but let's say for very accurate tooling where the tolerances are in the 1.5 to 2/10 range, and you need a piece of equipment that's better than that for doing the inspection. So 20, David, correct me if I'm wrong, 20-inch cube roughly on the MyCura?
500 millimeters, 500 millimeters, 500 millimeters.
Yeah.
Okay. Yeah. And so on both of these. Fairly small volume. Well, 20 inches actually isn't all that small.
No.
So submicron accuracy. This is what medical device perhaps, or what's the market for this?
Could be any area. I mean, some of the things that you would think, for instance, a pop can, where you have to have that click when you open the lid. You would think, oh, pop can, throw it away when we're done. Yeah. But the tooling to be able to produce that click of the lid it requires tolerances to be machined down to 1/10 and a half. Wow. And so, I mean, so there's an industry that you wouldn't think would require such a high degree of precision. But then other industries, clearly, the gear manufacturing industry, you get into blades and engine components, powertrain type of things.
Sure.
They all require, even medical, when we get into heart components and things like that.
And the MyCura and the F25, are these touch probe machines or scanners or?
The F25 is a combination machine, so both optical and tactile. Okay. The MyCura machine is a tactile measuring machine only. Okay. And when I say tactile, I mean scanning, full contact measuring.
Full contact scanning, but okay, right. There's also some software I believe you guys introduced, or maybe a software system or something that you guys introduced at the show, or has it been around for a while?
Well, we are showing it at the show. It is called PyWeb. It is a software package intended to take a facility who might have more than one measuring machine or more than one customer and allow you to ensure that all the data coming from your measuring machines or going to different customers always goes exactly in the same format. So it takes all of the results coming from all the different machines in your lab, consolidates them into a single report, and ensures that on that report it is in a format that your customer is expecting.
So these various equipment are networked together, is that?
That's correct.
Okay, and they communicate to each other or just back to a central server?
Back to a server, that's correct.
Now, this can be across multiple facilities, or is this local?
This could be done across multiple facilities. It could be within one facility, and it could cross any number of gauges. It doesn't even have to be just ZEISS. It could be any number of gauges.
Oh, that's interesting. So you guys have a way to pull information from other than ZEISS products, still pull that information off those products and get it into the system.
That's right.
Okay. Well, let's come back. Let's come back to you just in a little bit. We actually did have a couple questions come in that I want to get to here real quick. By the way, if you do have some questions for us, you can send them to techno-live@qualitydigest.com, and we'll get to them. I believe there is a question here for Alicia.
Mm-hmm.
Oh, how many hours, days, or weeks is the Occam course?
The outcome course is 4.5 days, so 4 days of in-class training, and the last day, which is a Friday, is a half day. It's for the exam and just kind of final follow-up questions and anything along those lines, because it is a certified course.
Okay, and by the way, you may have seen somebody join us on the set. We're going to be getting to this gentleman, Mark Miller, in just a few minutes. Mark's going to be talking about some of the microscope products from ZEISS, and we'll get to Mark in just one bit. I think there was another question here I want to get in. This is, I'm not sure what product they're talking about, but what is the current precision we can expect out of the laser system?
It's
David Wick. Okay.
The line scan scanners that are on our CONTURA have a figure of merit for precision of about 12 microns.
Okay.
So that's compared to a figure of merit of accuracy of about 1.5 microns on the machine itself.
Okay, so the CONTURA, and I guess I didn't follow up on this too much, but the CONTURA is a multi-sensor machine. You can have
no. You can attach the line scanner as an accessory to it.
Oh, okay.
So it's an accessory. About 12 microns is its figure of merit for accuracy.
Okay, and this is probably for Alicia. Is CALYPSO efficient to manage millions of points? Is it possible to create a 3D model out of the cloud of points?
With the line scan data, you can. We collect it in CALYPSO, and then you can utilize other software for the reverse engineering to create the actual CAD model itself. Because in CALYPSO, we read in CAD, but we don't build the CAD model. But we can pull in the points from the line scan data, and with the line scan, we can collect millions of points, export it out in pretty standard formats, and then that can be used for reverse engineering applications.
Okay. Kevin, this question came in from you. Do you do first article inspection or reverse engineering?
Yes.
Good.
Yes to both.
Okay.
Yes to both.
Yes,
and I should point out, really all we need to know from our customers is have a picture of the part. If they want to know what can we do, we just need a picture of the part and just a real brief description of what they're looking for. The kinds of services that we provide start with a blueprint, full fare is what a lot of people call it, but a full blueprint layout. We can do this on our measuring machines, or we can do it on our CT measuring machine. We can do a wall thickness analysis, we can do porosity analysis in our labs, and full assembly analysis as well. So a little bit of everything.
By the way, I should point out, one of your cohorts here at ZEISS sent in a correction, said that the Micura is not 0.8, it is actually 0.7. that 1/100th of a micron, it's instead of 800 nanometers, it's 700 nanometers, right? There you go. It's better than you thought, actually.
Yes.
That's with the vast XT Go. So what I got here is the Micura is not 0.8, it's actually 0.7 with the vast XT Go.
Okay.
There you go. That's from the people in the background back there.
We need those people.
They want to keep you honest. All right. We go back. We actually had a couple more questions, by the way. Now is the time to be sending in your questions. Send them to techno-live@qualitydigest.com. It can be on inspection, it can be on new equipment, it can be on microscopes here in just a little bit, or it can be on software. Let's go back to this question. Can you create measurement plans for customers? I'm not sure if that's Alicia or...
So many words used interchangeably, but in CALYPSO, the terminology we use when we create a program is a measurement plan. And so the answer to the question is absolutely. That's part of what we do as a service for our customers. Again, all we need is a CAD model if one existed, a drawing, and a little description about the type of machine that the customer has where we would need to deliver this measurement plan, and we can do it.
Now, what about the reverse? What if a customer already has an inspection plan? Can you take theirs and use it if they're hiring you out to do the inspection?
We do it all the time. Often we do it as a third party where they provide us with their fixture, with their tooling, with their measurement plan. They ask us to act as a third party, check the same parts, but on a different machine, one of our machines, and help to get in the middle of perhaps there's an argument going on. And so absolutely we can do that.
Okay. We'll have some more questions, but I want to be sure I get over here to Mark Miller. Mark, what is your position here at ZEISS Industrial Metrology?
optical and electron microscopy cells.
Okay, and tell us a couple of things that you guys got going here at the show.
ZEISS Microscopy is showing our fully automated particle analysis system for manufacturing cleanliness. These are based on ISO standards. They range from light microscopes, as you may have seen in the background here, all the way up to scanning electron microscopes, giving you information such as particle size, class distribution, all the way down to elemental analysis of an individual particle.
And so this is automatic. I'm assuming somebody puts a part in there, it scans it, it can count how many particles per cubic centimeter or whatever, and sort them out, right? By particle
Typically,
size.
this is based on a wash system where you take a fluid, wash a part, collect the wash water, run it through a filter paper. That's what you put on the microscope is the filter paper, scan the whole thing, analyze it, and do your distribution.
Okay. And you have another product as well. You have another product here as well,
yes,
right?
we have the Smart Zoom 5 digital microscope. This is brand new from ZEISS. This is ideal for the quality control, quality assurance type industries. The real uniqueness of this is the ease of use, the touchscreen controls, and the ease of smart workflows to create a seamless ease of use tool all the way from an experienced microscopist all the way down to an unexperienced novice user.
And I'm not real familiar with the microscope market. Is this mostly materials analysis, or is it inspection, or where are these products used mostly?
All of the above, everywhere from even biological. In our world, it's metals, plastics, automotive, aerospace, any industry you can think of. Somebody who cares about quality is going to use our instruments.
Okay. Now, one of the things, and I'm not sure who wants to handle, maybe David or maybe you, Kevin, is, we hear a lot about nanotechnology. There's a lot going on in that field. Parts are getting smaller and smaller. Is ZEISS working in that area at all in terms of being able to inspect these minuscule parts, maybe from microscopy point of view or anything like that?
Well, I can answer from. So one of the we've got into a strategic acquisition of a company who's now part of our group called X-Radia, and they are part of our microscopy line, and they fit in very well. So it allows us to use CT scanning techniques using X-rays, but to scan parts which are at a sub-micron level. So the CT scanners that we have now are always above a micron in terms of the resolution, and so our X-Radia product line takes it almost as good as certainly as good as any microscope, light microscope, but not quite as good as a scanning electron microscope. So it fits right in there. But the beauty, of course, is we have three-dimensional data sets that we're working with and visualizing with, and so that's one of the directions we're going when it comes to nano inspection.
Right, and CT is just something that just really amazes me. Let's talk about that a little bit. Before, when we used to talk about CT scanners, they didn't have all that great resolution. I mean, they've really come a long ways, right? I mean, you talk about just over a micron, a couple microns on the Metrology, something like that?
That's right.
So that really allows you to do types of inspections that you wouldn't have been able to do before.
Yeah, and it's not, I mean, the resolution, we've seen some improvement, but the real improvement has been quantifying the accuracy. So it's one thing to be able to see a detail. It's another thing to be able to quantify exactly the size or the shape or the location of that detail. And that's been the real dramatic improvement, is bringing accuracy to the world of computed tomography.
Okay. ZEISS is considered to be an innovator, a leader in innovation, right? So I'm sure you get a lot of, and we touched on this a little bit, a lot of requests from customers, for new products, new ideas. How does this need to meet customers' needs and do it quickly, and get a product out there that's going to meet a need that's already been given to you? How does that drive the innovation process and the integration process for products at ZEISS Industrial Metrology? What's that do for you?
Well, it makes the answer is it makes selecting the products we do much easier. If you've got a lot of feedback from a lot of customers in one market that says they want something new that stretches us, that's obvious business demand, so that gets a higher priority in our innovation process than ideas generated in other ways. So it makes it go faster.
Okay.
Do you mind if I add to that?
Go for it.
So because we use our own equipment in our measurement and programming labs, like Metrotome, like other pieces of equipment, one of the side benefits, in addition to providing the services to our customers, is that we really push the equipment to its limits, perhaps beyond even the things at a development level that we had hoped from the equipment. And so what it does is it gives us a very nice internal method, a mechanism, to feed back our findings as we're using the equipment back into the development system with David, so that as the equipment, as it matures, we can continue to innovate by taking a lot of the practical, real world lessons and building that back into the equipment to make it better and better and better.
That's interesting. So what I hear you saying is that as a developer, you're developing new equipment, you can try to think of how a piece of equipment or a piece of software is going to be used, but you can't foresee every possible way somebody's going to use it, right?
Even with all of our experience.
Correct. So what happens is somebody comes to you and says, hey, I need you to inspect this part. And you're saying, if I hear you right, is you're trying to inspect it with a particular piece of software equipment, and you realize maybe it doesn't do it quite as easily or quite as quickly or whatever as you would expect, and then you can feed that back to the development group?
Right back into the development group, that's right.
I know, I think you said earlier that a lot of the stuff you can't talk about because it's proprietary, but is there an example of maybe an improvement that you made based on just something unexpected that you saw out in the field, or would you have to shoot me before you tell me that?
I have something on top of my head, but go ahead.
No, we might have to shoot you, but we can't do that on TV, so we'll turn it over to Kevin.
Again, CT, one of the things that we discovered when we were scanning components, of course it's non-destructive, but one of the things that a customer does if they didn't have a CT machine is they would slice their product. So they would pot it, they would let the potting material solidify, they would cut it, and then they would look at that 2D slice of that thing under a microscope or maybe an optical measuring machine. So in the beginning, one of the first tools we had allowed us to slice apart digitally speaking, so let's say a digital knife, that allowed us to slice in any perpendicular orientation. So, the XY plane, the YZ, the ZX, and any number of increments. But one of the lessons we learned very quickly for rotationally symmetric parts is it would really be wonderful to be able to slice apart like a piece of pie. So imagine, you take to diagonal so that you could see the cross section of it going all the way around as you're looking at it. And then that drew in another idea, which was if you imagine if you had a piece of pie and you wanted to slice it all the way in. So having concentric circles which cut it, and so you're always looking at one slice of the pie, same radius, but all the way around. And so these were ideas that we were discovered, and now they're implemented in the software that we use today for doing analysis.
And really, you already had all the data already. It was just a matter of how the software is going to do the slicing, right?
Yeah.
Coming the routines for it. Okay. One of you guys got to add to that? Okay, I'm sorry. I thought I heard somebody saying something. Okay. Well, guys, I mean, we're kind of getting close to wrapping this up here, but I want to make sure that there's not anything that we've missed, or that any piece of equipment we want to talk about, or service, or.
From my standpoint, the only thing I didn't say that I would like to say is everyone in the audience should know that we are the experts. When you bring your parts or your business to us, we're doing it with ZEISS people in ZEISS facilities, and we're taking care of everything that way. We do not subcontract our work out. We do not subcontract the people that do the work. We do it internally with our equipment.
Okay. Dave?
Yeah, I was going to. The other point I would add is that everything we've talked about, the technologies, the products, the services, the software, isn't just done just for the fun of it. It's done because it all builds up into a solution that someone wants. And that's one of the strengths that an experienced company like ZEISS can bring to the party, is a solution. From teaching customers how to use it, to actually having it, to solving their problems, whether it's microscopes, CMMs, roundness instruments, or the whole range.
Okay. Actually, something you said just kind of brought a question to my mind, Alicia, is when you guys are developing your curriculum, and I'm thinking specifically your equipment-oriented curriculum, is that curriculum based on strictly, here, somebody from, development team says, look, here's what people need to know, or does this also come from the field where they say, you kind of would be hitting the big points with that, but there's a lot of things that operators on the floor need to know that may go beyond a little bit what just the specifics, push this button and, click here.
Yeah, it's a combination of both. It comes from developing through an educational perspective too. Like, what are the key concepts that would allow them to use this equipment or this software most effectively, right? So, what are the fundamentals that they need to know, and how do we teach it? How do we give them exercises and hands-on utilities to really reinforce it? And then, so we kind of build it up that way, and we look at it. Okay, if we go through basic, what are the absolute essential concepts that you need to come out of that class with? And then, so we look at it from a whole perspective and then build the different modules within the class to reinforce that. And it's a constant improvement process. We have new functions, new features that come in the software that we try to integrate into it. And we have new requests from customers and continuous improvements. Oh, it would be really helpful if we see this, or to really do some more exercises in this regard. And so we do incorporate that, and we are literally constantly doing an improvement process on our training material as well.
So everything is, kind of what I'm hearing from all of this is from, product development and education and inspection. It's all a very kind of integrated process where there's plenty of feedback going amongst all of you to make sure you're all kind of on the same page with what's happening.
Absolutely.
Yep.
And you're listening to your customers, and that's...
Well, that's a key that drives us forward, right?
Right.
We need to know what they want and what they need, and so we can help really tailor our innovation in that regard, and we can tailor our training so that we can support them and, like David said, provide a full, well-rounded solution.
Okay. Well, guys, I don't think we have any more questions here. This has been great. I appreciate it. Mark Miller, David Wick, Alicia Anderson, Kevin Legacy, all from the great team here at ZEISS Industrial Metrology here at IMTS 2014 in Chicago. If you're here at the show watching this, come by their booth. There's a lot of great equipment here. Otherwise, thank you for joining us at TechnorazziLIVE, and also be able to tune in tomorrow on Quality Digest Live if you're one of our regular viewers. We're going to be broadcasting our live show here from IMTS as well tomorrow at 10 p.m. Pacific, I believe. There we go. At 9 Pacific, at 9 o'clock Pacific, Quality Digest Live here from the IMTS show 2014. I got people talking in my ear here. So thanks everyone for. Oh, we got one more question. All right. We were just going to leave, and here we go. One more question. All right. What is your contact info for the Maple Grove facility for contract first piece measurement? And if you don't know that off the top of your head, we will just...
I don't know off the top of my head.
Well, Tom, we will email you that information in case you're wondering. Tom's question, contact info for Maple Grove facility. Tom will email that to you after the show. Be sure we get that out to you right away. So once again, thanks to all of you for joining us for TechnorazziLIVE, and we'll see you at the next one. So long.
Oh,